key word of SR2S, that is collaboration. Let me say that competition is basis for healthy functioning of the market, but collaboration is fundamental to development. And SR2S is an example of winning collaboration between industries which often compete for the acquisition of orders. Partners have worked together to reach a common goal, each one dealing with specific problems, but all of them taking advantage by the progress of the other. As regards industrial development, SR2S team has dealt with a crucial issue for interplanetary human mission. The study of the scientific case was faced by the industry for the first time. Before SR2S, only some academic studies were carried out, neglecting the engineering perspective. SR2S has covered this gap, defining engineering requirements and an overall shielding concept. The SR2S study has developed the know-how on critical radiation shielding technology, fundamental to enable human exploration mission beyond Earth orbit. SR2S team also faced the problem of the 3D advanced Monte Carlo simulation using Giant 4 to study the transport of radiation particles in the magnetic field and in matter. The industrial team acquired skills in space particle physics and a deep knowledge of the involved electromagnetic and nuclear processes. Of course, studies of the interaction of space particles with the magnetic field and matter has been done in the past, but for the first time the radiation particles were propagated to complex structure and magnetic field in order to calculate biological risk. The project also allowed the industry to work on innovative structure for superconducting magnets, fitting the problems related to the behavior of materials at low temperature. And they faced also the problem of designing thermal controls. Of course, this was an already established activity, but in this case, this was applied and was never done before to complex dynamic parallel systems. So, as regards industrial returns, thanks to SR2S, Thales Alenia Space masters Giant 4 to evaluate the radiation dose inside spacecraft and has acquired a deep know-how in both traditional and active shielding methods. CGS acquired the capability to design a mechanical structure operating at cryogenic temperature and consolidated the capability to design thermal controls for cryogenic systems. Columbus Superconductors developed the technology to produce light conductors that can be applied not only in space, but also in power generations and in medicine. A particular requirement of lightness, of low mass magnets, is for the beamlines for the cancer hadron therapy. This is a possible application. Last but not least, let me say that important return of SR2S is the training of young engineers and physicists. Often, innovation comes out from the mind of young people if they are trained in a fertile background. The research projects like SR2S look at the far future. Consequently, they are academies where young engineers and physicists can express their creativity and propose new visionary solutions.